Rebalancer is a web-based simulation testbed system which provides interactive visualization of the dynamic rebalance of shareable bikes among docking stations, in order to better serve fluctuating demands. It can simulate and evaluate rebalancing schemes under various conditions, together with visualization of the AI decisions, the movement of bikes, as well as the trucks used to transport bikes for rebalancing. Through simulation with real-world dataset of London bike sharing system retrieved from the Transport for London website, Rebalancer demonstrates the effectiveness of the implemented spatial-temporal rebalancing algorithm, which rebalances shareable bikes based on queuing system dynamics and Lyapunov drift. Nowadays, bike-sharing systems are widely deployed in many major cities, but many system operators are facing a costly maintenance challenge. The fluctuating demand and irregular flow patterns of bikes causes either congestion of deficiency of bikes in different stations, causing inconvenience for users and severe customer loss for the business. Many researches have been conducted on how to efficiently rebalancing bikes using AI-based optimization. However, there is no such a testbed system which could provide visualization of the simulation and evaluation of different rebalancing schemes. Rebalancer is designed to test rebalancing schemes and visualize the rebalancing simulation. The web-based application displays a map of the operating area of the bike-sharing system, and uses circles to represent each dock station. The size of each circle is controlled by the number of bikes in the station at each moment. On the left of the map is a control panel for the user to control and view the result of the simulation. The settings section of the control panel is for the user to set the simulation parameters before starting the simulation. Parameters that could be set include the cost of moving each bike in peak and off-peak time, total budget allocated for rebalancing bikes at each time interval, the coefficient of cost in the joint objective function, and the prediction mode. The prediction mode controls the prediction algorithm, to be selected from past 7 days moving average, long short-term memory, gated recurrent units, and bidirectional LSTM. The controls section allows the user to control the simulation progress and displays the current simulation time. The last section of control panel displays statistics of the simulation, such as the current cycle count, cost of rebalancing bikes and cumulative rebalancing cost up to current cycle. After the simulation is ended by the user, it will display the summary statistics of the simulation result and provide an export button for the user to download the simulation result. Here is a demo using the real-world data of 773 stations in the London bike sharing system on the day of October 1, 2018. Before starting the simulation, we can set the cost of peak hours as 2 and the prediction mode as GRU. After setting all parameters, click on the Start button in the Controls section of the control panel to start the first simulation cycle. Then, upon clicking on the Rebalance button, the movement of trucks redistributing bikes among stations will be shown on the map. Let's see a rebalance at 6 a.m. on that day. This new cycle is started by clicking the Next Cycle button after the previous cycle from 4 to 6 a.m. finished. Then, upon clicking Rebalance button, stations not involved in this cycle's rebalancing operation are hidden from the UI, while stations with trucks moving out are represented by red color, and stations with trucks moving in are represented by green color. The numbers of bikes and stations involved in the rebalancing are also shown in each circle. The numbers of bikes moved between stations are shown on the blue trucks. The numbers of bikes in each station are also updated accordingly when the truck leaves or reaches the station. Due to the large number of trips to move bikes among stations, they are displayed in batches in UI, with the progress shown on the right bottom. However, they are actually performed in parallel in practice. Next, after the rebalance is finished, click on the Simulate Rides button. The movement of bikes by riders during the time interval of this current cycle will be simulated, updating the bike counts in each station. This marks the completion of this current cycle. Clicking on the Next Cycle button will start the simulation of the next cycle. Then the user can click on Rebalance, Simulate Riders, Next Cycle and so on. To save time, the user could also use the functionality of advancing several steps. Upon clicking on the Advance button, the simulation progress would advance for the selected number of steps, without displaying the simulation animation. After simulating 1 day of rebalancing, click on the Finish button to end the simulation. The summary statistics of the simulation result is then displayed in the Statistics section of the control panel. Clicking on the Export button will allow the user to download the simulation results in CSV. The download files include the data of simulation setting, simulation result, the statistics of all cycles and the demand-supply gap for all stations before and after the rebalance. All historical simulation results are stored and can be viewed by clicking on the View Simulation Records button. The records are displayed in the table format, which shows the settings and important statistics for each simulation. The user can also download or delete the record of certain simulation. Rebalancer is an AI-powered visual simulation testbed system which provides interactive visualization of the dynamic rebalance of shareable bikes among docking stations. This system would not only allow researchers to test their rebalancing schemes, but also crowdsource solutions to the rebalancing problem, by engaging public users from different backgrounds to use their collective intelligence in exploring decision-making in the simulation.